Hello friends, this is the continuation of solution for the question paper June-July 2024 of microcontroller examination. We are taking continuation from module 3 as well as module 4 in this session. Starting with our module 3, question 5a, explain TMOD TCON registers of 8051 and this is for 10 marks. So you have to consider TMOD register complete configuration first, and then after you have to explain each of those bits as it has been done over here, and elaborate this mode by making use of this tabulation method. Then after you have to take up on the TCON register. Here is the TCON register. Write down the 8-bit configuration of the TCON register and mention what each of those bits are meant for. So make an explanation something like this in a clear cut manner. So this much will be sufficient for this one. Next question. Assume Xtal is equal to 22 megahertz. Write an ALP to generate a square wave of frequency 1 kilohertz on pin 1.2. This is for 10 marks. Observable matter. So which timer we have to make use of and in which mode it has to be done. So that is not given. So we can make a consideration by ourselves. In this particular solution, timer 0 in mode 1 is considered. Based on that, the calculation has been done. So square wave of 1 kilohertz that has been asked, that is equivalent to 1 millisecond. So here is the square wave representation. Total on time plus off time, it is 1 millisecond. So either we take the on time or the off time, then it is going to be 0.5 millisecond. So our count value is now limited for the duration of 0.5 millisecond. So here is the formula for that. So we are considering 0.5 millisecond as the delay, and 22 megahertz is what the oscillatory frequency that has been mentioned in the question. Based on that, we are going to get the value 917 in decimal, which is equal to 395 in hexadecimal. So now the value to be loaded to the TL and TH is what is represented over here. FC6AH is what we are going to get. Right? That's what the values we have loaded here. And for that, the program is written over here. So try to make a follow-up. So for all the square wave generation, we are going to have the similar kind of programming methodology, provided if you are making use of timer 0 in mode 1. Next one, explain. First one, SCON register. Second one, importance of TI register for 10 marks. See, TI register is a part and parcel of the SCON register itself. So we are not going to have any exclusive solution with respect to this TI flag. Anyway, we are going to mention 2 points for this one. So let us start with the first one, SCON register. So write the 8-bit configuration of the SCON register, then represent what each of those bits are meant for. In continuation, so represent the mode of different modes of operation, elaboration of the previous thing. So just elaborate it, and then what these bits are meant for, just try to elaborate to the little extent. In continuation, importance of the TI flag. So TI stands for transmit interrupt flag. So importance is only represented in 2 points, only that much we can do with respect to this TI flag. Now getting into the next one. Write a C program to transfer YES serially at 9600 baud rate, 8-bit data, 1 stop bit. Do this continuously. So this is for 10 marks. So now notable thing, 9600 baud rate. So baud rate is being given. Characters to be transmitted, it is what? YES. So 8-bit data, 1 stop bit they have given, and we have to put this in an infinite loop. Right? So that means the configuration for this is fixed. The SCON value will be fixed for this one. So now we are going to have configuration for this one. So TMOD register we are going to make use of in order to use the baud rate. So timer 1 is what we are going to configure. Timer 1 in mode 2 for T mod. For this configuration, we are going to have the T mod value as 0x20. Then baud rate value 9600. So its equivalent representation is 0xFD. That will be loaded to the TH1. So since it is in mode 2 operation, this value will be repeatedly loaded to the TL1. That is auto reload procedure is going to be done every time. Then SCON register we need to configure 0x50. That is what the 8-bit data, one stop bit is what, and variable baud rate option is provided within this configuration. So we are going to make use of this configuration. Now start the timer so that we can keep counting the baud rate operation. Now start the transmission. So serial transmit is a function. So every time when we call, we are going to transmit one character YES, and here is the function part. So whatever the character we are passing from here, that will be received over here into the variable X, and then any data to be transmitted serially must be there in the SBUF register. Therefore, it is being transferred to the SBUF. Then until transmission gets completed, stay in this particular statement. That's why semicolon is used here. So once Ti is equal to 1, it indicates transmission completed. So it will come out of this while loop. Then make Ti is equal to 0, move back to the main part of the program. Right? So this has to be kept in an infinite loop. Therefore, we are using while of 1 representation here. Right? Now getting into the module 4. Now the question here, define interrupt, list the steps involved in executing an interrupt. This is for 10 marks. So first make the definition for interrupt. An interrupt is an external or internal event that interrupts the microcontroller to inform that the device needs its service. So this is the definition. Then what is going to happen when an interrupt occurs or during the execution of an interrupt? So these are the various steps that are available that is going to happen while executing an interrupt. So we have to mention all these steps. So if possible, so try to make use of a programming example so that you can elaborate this concept so that it can match for 10 marks. Right? Try to provide a small programming examples which is having an interrupt, then make use of the return interrupt instruction over there. You can write a pseudocode, not exactly the code is required. So pseudocode you can just mention, and you can just brief it over the program how the things are going to work with respect to these 4 points. 7b, explain interrupt vector table of 8051 microcontroller. So this is for 5 marks. So which are all the interrupts we are going to discuss? So its location has to be mentioned and which pin it belongs to if it is there, or which port pin it belongs to, that has to be mentioned. So these are the various interrupts we are having: reset, then external hardware interrupt INT0, timer 0 interrupt, that is TF0, external hardware interrupt INT1, then timer 1 interrupt, that is the timer TF1. So timer 1 and timer 0 related interrupts are timer overflow interrupts. Then with respect to serial communication, basically we are having 2 interrupts, RI and TI, but together we are going to refer to one common ROM location. Therefore, this is being mentioned as one single interrupt realization. Whenever these interrupts are going to occur, then the execution will go to this particular location. You have to memorize this location. Further, so if there is specific pin within the 8051, it is good to mention that one, or if it belongs to any of the port pins, good to mention that one. Otherwise, you can leave it blank. So you can make out any small brief explanation on this one. Explain interrupt enable register. This is for 5 marks. So mention this 8-bit configuration of interrupt enable register. Then what each bit is going to perform, you just make a list of all those things. So here it is being simply done. For example, EA is enables or disables all interrupts. It is a simple representation that has been given. If you want to try to elaborate it, if it is enabled, what is going to happen? If it is disabled, what is going to happen? Enable means what? Disable means what? So in this case, you have to remember that all are active high. If you set it equal to 1, then it has enabled. If you make it equal to 0, it is disabled. That's the concept. So you can elaborate it by saying if EA is equal to 1, then if EA is equal to 0, what happens? So you can just elaborate it. So like that, for all the bits, you can do that. So now 8A, explain interrupt control used in 8051. So this is for 10 marks. So enabling and disabling interrupt using interrupt enable. So that's what we are going to have the explanation over here. So there is no direct definition or anything like that. So we must consider an example over here, and then we have to make a clear description about how these things are going to work like. So that's why an example is being taken by making a consideration of all these things. So A, B as well as C, 3 examples are being taken. For all of this, programming representation has been done. Then how these things are going to work, you can have a clear description about it. Remember, solution for A, either you can write this one statement or these 4 statements. So all this stands with the same meaning. So by making use of these theoretical concepts, you have to provide the sufficient description for this one. Coming to 8B, explain the steps involved in programming serial communication interrupt. So this is for 5 marks. See, there are few steps available over here. So you have to list all these steps in a clear-cut manner. Then after, you must also mention this diagram so that how this Ti and Ri are connected to the common interrupt vector location. Now 8C, explain how multiple interrupts are handled in 8051. This is for 5 marks. So this is concerned with the interrupt priority register. So for that, mention the 8-bit interrupt priority register. Then after what each of these bits are going to perform, make a proper listing of that as it is done in this table. Right? You can also have a consideration within yourself that if priority bit is equal to 1, assigns the highest priority, if 0, assigns the lowest priority. So you can show this by considering a small example. Either you can assume a theoretical example for this, or you can take out 2 or 3 instructions and represent how the priority has been assigned. If you assign such priority, then how the priority will take upon, which one will go first for the execution, which one will go next for the execution. You can put the importance of multiple occurrence of the multiple interrupts and how it is being handled with the interrupt priority register in case of interrupt priority register. Right? You can just elaborate it with a small example and few wordings for that. So we will again join with the 5th module in the next session. Thanks for watching.